All right, let's do some practice with lesson 1 and 2 of Unit 7. All right, so we'll start with graphing. This is back from Unit 1, just graphing a logarithm and an exponential function. We're going to start with f of x equals 4 to the x. So you're going to need Desmos or your calculator. All right, so I'll type in y equals 4 to the x power, and I'm going to make a table. So pause the video, copy this table over, and then we will talk about graphing it. All right, you should have this function graphed. I wrote the fraction and the decimal approximation for the table. So 1.0625 is 1/16, and 0.25 is 1/4. Remember, when you do the inverse here, you switch the x and the y. So from the original table, these two columns switch. So you would start with 1/16, 1/4, 1/4/16, and then the y column becomes the x's from the original. And you should be able to plot those on your grid. So you have 1/16, -2, 4, 1/16, 2. All right, and that's f inverse of x. And the original was f of x. Now for that original graph, I'm in the box underneath the graph here. For that original graph, there appears to be an asymptote at the x-axis. For our inverse graph, the pink one, our asymptote was at the y-axis. We also talked in those notes that all inverses reflect over the line y equals x, which is the line that goes through the origin with slope of 1. Right? So you should see that the purple and the pink graph reflect over that green line. The inverse you graph, the special name for the inverse, is called a logarithm. Remember, the inverse of an exponential is called a logarithmic function. Okay? Now the bottom of this is a bunch of multiple choice. I'm just going to do a couple of them. Just making sure you understand the phrasing. So you're literally going to translate the English statement into a math statement. So it says the logarithm base 2 of 16 is some number. If you're not sure, write it down as you read it. The logarithm base 2 of 16 is some number. We're going to call it x. Well, which one does that match? It matches question D, or part D. Okay? So translate it, write it down as you go to translate from English to math. All right, you're going to try those other three. Now flip over to number 6. We'll look at number A here. We're using the definition of a common logarithm. All we're doing is the curlicue. We're rewriting this as an exponential. Don't get caught up in the formal definition. Just turn this into an exponential function. The way you do that, take the base, curl around to what you're equal to, and with the number inside. So it should be 3 to the 3rd power equals 27, which, if you checked on Desmos, should make sense because 3 to the 3rd equals 27. Try the other ones there, and now let's flip it around. Number 7, 10 to the 4th equals 10,000. We're writing that in logarithmic form. Always do your curlicue. Start at the base, go out to what you're equal to, and up high. Log base 10 of 10,000 equals the exponent of 4. The logarithm always equals the exponent. Now, you should remember here that any logarithm with a base of 10 is called the common logarithm. So if I wanted to, I can write this logarithm without the base of 10. I could write it as log of 10,000 equals 4. Here, the base of 10 would be implied. All right, number 9, we're going to solve some of these. We're going to do 3 at a time. All right, let's solve for x. Remember, to solve a logarithm, you need an exponential because to solve anything, you have to use inverses. So you make a curlicue to turn this into an exponential function first. 3 to the 4th equals x. Now, I would just use Desmos. 3 to the 4th is 81. So we have 81 equals x, and that's your final answer. in x here, I make my curly Q again. I have 4 to the 0 power equals x minus 1. Well, remember, anything to the 0 power equals 1. And I'm going to go ahead and add 1 to both sides to get 2 equals, 2 equals x. All right, and finally, h. Make your curly Q. 3 squared equals negative 2x minus 7. 3 squared is 9. We're going to go ahead and add 7 to both sides. I'll get 16 equals negative 2x, and I'm going to divide by negative 2. That'll give me negative 8 equals x. That's my final answer. There are like 6 other problems to try there, so if you're not sure about those 3, try the other ones and make sure you're understanding. All right, let's finish here with a couple natural log base E problems. All right, so we'll do 10a. All we're going to do is write this in logarithmic form. Now, I could write, when I make my curly Q, I could do log base E of 17 equals P, but that's not what we want. Remember, log base E is called a natural log. So we have to use the ln, natural log. Now, you can put base E if you want to. Natural log of 17 equals P, but the convention, or the way to do it, would just be to write ln, or natural log of 17, equals P. You don't need the E there. All right, and then 11a, last one. Write this in exponential form. Well, remember, the natural log has a base of E. If I make my curly Q, I have E to the 10th equals x. And that would be your final answer. All right, if you have other questions, check the key on Canvas or ask your teacher for some help.